We are going to talk about triangle congruence today and how to prove that triangles are congruent. So congruent polygons have congruent corresponding parts. So the corresponding parts are the parts that are in the same spot in the two different polygons. So when you name corresponding polygons, you must list the corresponding vertices in the same order. So in trapezoid A, B, C, D, you would want to write a congruent statement. So this is what we're doing right here, congruent statement, keeping the vertices in the same order. So if I'm starting at A, so I would say A, B, C, D. So I went from A to B to C to D. And I would want to do that same order in your other one. So you have to imagine that that trapezoid is rotated to the left, where you would start with X. So we would say X, Y, Z, W. And that would be our congruent statement for those polygons. So we have a triangle congruent statement saying that triangle IHJ is congruent to triangle BCJ. So down at the bottom, I want to know which angle would be congruent to angle I. So there's two ways that you could look at this. You could look at the congruent statement and see if you have angle I is in the first spot. So to be matching up with that, it would have to be in the first spot in your second triangle, which would be B. So that means that angle I would be congruent to angle B. That's one way that you could do it. You could also look at the picture, and angle I, right here, has one arc. In your other triangle, the only angle that has one arc is angle B. So matching up the arcs that are the same, you would get angle I is congruent to angle B. So now I also want to know which segment would be congruent to segment JC. So two ways you could do it. You could look at the picture and say that segment JC has two tick marks. So over here we have two tick marks, and we're going from 3 arcs to 2 arcs. So from 3 arcs to 2 arcs, it would be segment JH. Or you could look at the congruence statement where we have triangle IHJ congruent to triangle BCJ. So if I want what would be congruent to JC, so JC goes from here to here, then you would do the same exact movement in your first triangle. So from J to H would be what we have, and that is what we have right here. So now we'll talk about the different ways that you can prove that you have congruent triangles. There's some theorems and postulates that we'll look at, and these ways you can use to say that you have congruent triangles. So the first way is the side-side-side congruence postulate, or usually just referred to as SSS. So what it tells us is that if you have 3 sides of a triangle that are congruent to their corresponding parts, then the triangles are congruent. So in this picture, we have MN is congruent to QR, we have NP is congruent to RS, and we have MP is congruent to QS. So since we have 3 sets of sides that are congruent, then we know that the triangles are congruent. We know that triangle MNP is congruent to triangle QRS. So our second way is side-angle-side congruence postulate, or SAS for short. So what this says is if you have 2 sides of a triangle that are congruent to their corresponding sides, and the angle formed by those sides is congruent to its angle, then the triangles are congruent. So in our picture, PQ would be congruent to WX, QR is congruent to XY, and then they both form that angle, angle Q and angle S, and the angle that they form is congruent. So you have a side, an angle, and a side, angle, side, angle, side. The angle has to be in the middle. That is very important. So now that you have those things, you can conclude that triangle PQR is congruent to triangle WXY. So our next one is called the angle-side angle congruence postulate, or ASA for short. And what this says is if two angles and the included side are congruent to the corresponding parts, then the triangles are congruent. So angle A is congruent to angle D. Angle C is congruent to angle F. And then the side that they make, so in this case AC and DF, they are congruent. So we have angle, side, angle, angle, side, angle. So those triangles, triangle ABC is congruent to triangle DEF by angle, side, angle. Making sure that the side has to be in between the two angles. So now our next one is the angle-angle-side congruence theorem, or angle-angle-side, AAS for short. If two angles and the side not included are congruent to the corresponding parts, then the triangles are congruent. So this one can get very confused with the one that we just looked at, angle-side angle. The biggest difference here is that the side is not in the middle. So what I mean by that is if you have a triangle and this angle is marked off and this angle is marked off, you could have this angle, that side, or this side, as long as it is not the side in between the two angles. So in our picture, we have angle A congruent to angle D. Angle C is congruent to angle F. And then a side outside, we have side BC is congruent to side EF. So we have angle, angle, side, angle, angle, side. Going in order. We do not have that side in the middle, so AAS. So we know that triangle ABC is congruent to triangle DEF by angle, angle, side. And now our last one is called the hypotenuse leg theorem, or HL for short. And this is only in right triangles because you can only have the hypotenuse if the triangle is right. So this says if the hypotenuse of one triangle is congruent to the hypotenuse of another, and a set of corresponding legs are congruent, then the triangles are congruent. So in our picture, this would be our hypotenuse. So we have the hypotenuse here, and we have a hypotenuse here, or H for short. And then this is a leg, and this is a leg, and these would be the corresponding legs. So we can say that triangle ABC is congruent to triangle DEF by HL because they have the hypotenuse is congruent and the corresponding leg is congruent. So now this doesn't prove triangle congruence, but it's just something that you could use while you are trying to prove it. This is called the third angles theorem, and it says if two angles in a triangle are congruent to two angles in a different triangle, then the third angles have to be congruent. And just thinking about it, it should make sense. If we say that this angle is 40 and this angle is 60, and then they match up, so 40 and 60. In the left triangle, this would have to be 80, and it would have to be in the other triangle too. So if you know that two sets of angles are the same in two different triangles, then the third one has to be the same too. Okay, So now I want to look at these sets of triangles, and I want to know if they are congruent. If yes, how? And if yes, write a congruence statement. So we have these triangles below. They have two sets of congruent sides, but they also share that side in the middle. They share JK. So they have 1, 2, and 3. They have 3 sets of congruent sides. So this would mean yes, they are congruent, and they are congruent by S, S, S. So our congruent statement would look like triangle J, H, K. Now you could be going in a different order, but if your order is different, then the order of your second one will be different too, because the order matters. So I went from J to K, so I went through a single tick mark side, and then through a double tick mark, so I need to go in the same order. Through a single, and then through a double. So that would mean J, L, K. Okay, so same questions. Are they congruent? How? And write a statement if they are. So I have one set of sides. I have a set of angles. Yes, they are right, but that means they have to be congruent too, because all right angles are congruent. And they also share side DB. So I have a side, an angle, and a side. Side, angle, side. And making sure that it's the same thing in your other triangle. I have a side, an angle, and a side. So yes, they are congruent by side, angle, side. And your statement would look like triangle A, B, D be congruent to triangle C, B, D. Okay, so we have a set of sides, and we have a set of angles. They also share side PR. So we have a side, and an angle. And then our other one, a side, and an angle. So S, S, A, S, S, A. So this is not one of our choices, SSA or ASS. That does not work. But these are right triangles, where this would be your hypotenuse, and this is a leg. So yes, these are congruent by H, L. And our statement would be something like triangle SPR is congruent to triangle. So SPR, I went through a single and then through a double. So it would be QRP. Okay, so we have another one, same questions. We have two sets of angles, and they also share that middle side. So we have an angle, another angle, and this side. We have an angle, a double angle, and then this side. So angle, angle, side, angle, angle, side. So we have two angles on the side that is not in between them. So this is a yes by angle, angle, side. So triangle LJK is congruent to triangle. So I went from no arc to a single and then a double. So I'll go from K, which is no arcs, to M, to L. No arcs, single, and double. Now our last one. Are the triangles congruent? All those same questions. So I now know that X is the midpoint of BC. So BC, X is the midpoint. That means it splits that into two congruent parts, so that has to be the same. And X is also the midpoint of AD. So that gets split into two congruent parts. And we also have a set of vertical angles. So, drawing that outside of the picture, I have SAS, side, angle, side, angle, side, in both of them. So this is a yes, by side, angle, side. So I have triangle, I could say AXB is congruent to, so I went through a double and then through a single. So triangle DXC.